All right, good morning, everybody. My name is Omar Osmani. Some of you in the audience may have worked with me in the past. I am the security analyst at the CCC Tech Center. So today I'm going to give a presentation on open source intelligence, also abbreviated as OSINT, O-S-I-N-T. So the definition of OSINT is broad, and there has actually not been one agreed upon way to describe it. But we do have a definition from the Office of the Director of National Intelligence, which defines OSINT as any intelligence produced from publicly available information that is collected, exploited, and disseminated in a timely manner to an appropriate audience for the purpose of addressing a specific intelligence requirement. So these sources of information that could make up this intelligence could be pulled from any publicly available information. So there is no strictly defined methodology or sources of information to choose from. With that in mind, information sources can range from media pieces such as newspapers, television, social media, including Facebook, Twitter, Instagram, and LinkedIn for professional information on somebody. We could also find information directly from IT resources such as Linux servers open to the internet, Jira pages containing source code for an application an organization is developing, log files, and much more. I will show some examples later on of these. So OSINT can create opportunities for both security teams defending the organizations and also threat actors who want to discover weaknesses that can be exploited or information that can lead to a successful data breach. So I'm going to be brief here discussing the history of open source intelligence. So as a loose framework for intelligence gathering, it can actually be traced back to the establishment of the Office of Strategic Services in 1941 by William Donovan. This was during World War II. And this organization was basically the precursor to the CIA. They had a research branch, and what they would do was collect clippings from newspapers, journals, and radio broadcasts from around the world to gain insight on enemy forces. So specifically, they pulled information from obituaries, images of battleships, bomb craters, and aircraft to assess the state of the other army that they were fighting. All right, so why is OSINT important? So as you kind of tell already, using open source intelligence techniques on your own organization is important because it could tell you where you are vulnerable and what potential threat actors may come across when researching your organization or using the same techniques themselves. So the first thing is identifying unintentional leakage of sensitive data through social media networks and other publicly available platforms you may have. Also, you can also find information from previous data breaches. I'll get into that later. Another thing is finding insecure devices connected to your organization's network with open ports. So as discussed in the previous presentations, one of the common attack vectors is OpenRDP and OpenSSH. Another thing you can find doing an OSINT search is obsolete or updated or software that hasn't been updated, which can be exploited and lead to breach. And then finally, you have the potential to find confidential information, such as PII that isn't encrypted or encoded in, let's say, a log file or source code. So other pieces of information that can be of importance include like different search queries for organization that can lead to information on its technical infrastructure, how its environment is set up, and what components they're using. Another thing can be employee activity on online discussion forums and then assessing the nature of information that's shared within those. What else? We also have contact information as well as information available to an organization's employees available on the internet. So somebody who wants to conduct a phishing attack could find your employees' emails and start from there. So what are the end goals of OSINT research? Well, it depends on if you're defending yourself or if you're a threat actor. Now, so this is in the case of a threat actor. Usually, it will be social engineering via, finding an email address, wanting to start a spear phishing campaign based off of the information they find on your employees. They want to find open, they want to find open ports to the internet. So RDP, like I said earlier, is a common one. Another thing, finding PII, hiding in plain text, whether that be source code, database files or log files. So when conducting, open source intelligence research, there are unique keywords, tokens, and artifacts that we could use to classify data. So the examples include these, but they're not limited to the following. So we have name, email, birthday, IP address, MAC address, phone number, home address, license plate, and yeah, we have more. Basically anything that could lead to information on an individual or an organization. So when you first start off in OSINT search, you may only have one or two identifiers to work with. So this is where pivoting comes in. Basically, you have to search for the same identifier across different data sets. And you do this in hopes of finding more identifiers from those data sets so you can widen your research. So although I stated earlier that there is no standardized workflow for performing OSINT, there are some common techniques we could look at. So this one I stole from OOPS. For those who don't know or have not heard of them, they're called the Open Web Application Security Project. And as their name suggests, they develop free resources on web application security. So lots of information available. These days, the issue is analyzing the information accurately and making sure the sources of information are legitimate. So they came up with a few steps on doing this properly. So there are two types of OSINT research. One is offensive and the other is defensive. So offensive is where we gather information before an attack, and then defensive is where we learn about attacks against our organization. So I couldn't find any numbers on the ratio to bad to good actors using OSINT tools and techniques, but on both sides, the process is abstracted as follows. So step one is identifying the source. Basically here, we ask ourselves, where can we find information? The second step is harvesting. This is where we get information that's relevant to us from the sources we identify. Third is data processing. So this is where you process the acquired data and extract meaningful information that can make a lead. Fourth is analysis. We pull and analyze the data from the multiple sources we found. And finally, we have reporting. This is where we create an organized report on the findings. So there are two popular tools I'll go over from here. Hopefully I can get through all of them. Before that, I'm gonna go through not a tool per se, but it's a technique known as Google Dorking. So before we start, I do have to give a disclaimer that we're only using this for educational purpose, and any misuse is on you. So Google Dorking is also known as Google hacking, and basically this is where we're utilizing the Google search engine, and we're utilizing some of the features that come with it, including flags, filters, operators to perform OSINT research. So the type of information we can find are exposed critical directories of web servers, vulnerable files and web servers open to the internet, files containing username, password combinations, and then things like sensitive online shopping info, PII, such as credit card info, stuff of that nature. So before we get into the actual searches, I'm going to talk about how search engines work and then some of the operators we commonly use. So inside of a search engine, the component that performs the actual searches is called a crawler. So what these crawlers do is they discover content on websites. So one is by pure discovery, where a URL is visited by the crawler and the information regarding the content type of the website is returned to the search engine. So there are lots of information modern crawlers can scrape, but we will discuss how this is used later. Another method crawlers use to discover content is by following any and all URLs from previously crawled websites. So the crawler will basically want to traverse everything it can. So once a crawler discovers a domain such as mywebsite.com, it's going to index the entire contents of the domain. It's going to look for keywords and other miscellaneous information. So in this diagram, we have mywebsite.com. This one has been scraped and it found the keywords apple, banana, and pear. So these are stored in a dictionary by the crawler and then returns this to the search engine. So because it's stored in a dictionary and the search engine knows that the domain is mywebsite.com has these keywords, when you search for these keywords, this website would appear. Now, your search results depend on how many times the website itself has been crawled. So with most search engines, we can filter through the index data using operators. And these operators are the primary means we perform Google Dorking with. So cache basically shows a cache version of a website. We can find old versions of websites like this. All in text searches for specific text contained on a web page. All in URL finds various keywords in a URL. All in title restricts results to those containing terms in a specific title. Link list web pages that have links to a specified URL. Site is a full list of index URLs for a specific domain or subdomain. File type looks for files with a specific file extension on a website. So let's say .txt or .pdf. So this is a wildcard, and this is used to search for pages that contain anything before or after the word you specify. So this one is a logical operator. This is an OR operator. So I could search for multiple keywords exclusively with this. So plus is used to concatenate words together, and it's useful to detect pages that use more than one specific keyword. Then we have minus. This one avoids showing results that contain certain words. So there are many operators here, but the main ones we use are file type, cache, and in title. Right, so now I'm going to show a few examples. All right, so the first one is going to be just site. We do bbc.com and look for file type PDF. So basically on the BBC News website. Sorry, can you guys actually see my screen or?
Yes.
Wait, so this is paused.
So you can see Google Dork examples.
Yeah, that's not right. Just a sec. Sorry about that. Once again. Okay. So basically here I'm searching the British news website, and then I'm going to look for PDFs on the website using the operator file type. So Google search, and as you can see, this found PDF files only. So I'm not going to download these, but you saw how that one works. Okay, next, I'm going to look for webcams that are exposed to the internet. So a common one is one called webcam XP5, and this is from the Windows XP era, as the name suggests. So the untitled webcam. And as you can see, these webcams are assigned a public IP address. They're completely open to the internet. And in order to basically, since this was designed, I believe like 17 years ago, they didn't really think it through. And by default, once you install this webcam, you basically give it a public IP address, and then from there you can control it. So there were a few ones that I had saved. This one, yeah, okay. So here you could find some. You could find some front porch of somebody's house sitting here, and in some cases you can control them. I don't know why it's not working here. Just a second, let me try this in Chrome. Yeah, as you can see, I could actually move this webcam around. I can zoom in and out of it, and basically, in some cases, you could find like offices, public areas open, and then intel agencies can use those to gather information on that specific location. So it's actually pretty scary. Right. So next up, we have all in text. And then we're going to look for usernames. Then we want to look for log files. So I'm going to do file type log. So basically, this search for file types within extension .log, and then it's going to search for strings containing username. So with this one, you have to keep digging around, but eventually you find a user password combination, sitting in plain text. So I'm just going to go through a few of these and see if we could find a password here. That one's not loading. Interesting. Okay, so we found a WikiLeaks, and oh, this one doesn't have the password. Okay. So when I was looking through it last night, oh, here we go. I was able to find a few passwords, but yeah, like I said earlier, you have to do some digging. Okay, next up, we're going to look at file transfer protocol servers. So untitled. I'm going to look for an index page. So I'm going to do index of. Then we just type in URL FTP. So basically, this one finds index pages that are associated with the FTP server. And then using this, you could find internal information about an organization if it's sitting on those servers. And then if the server is in a write status, there is a risk of the server being used for storage of malware. So here we just go in, see different directories here. And basically, if you're doing OSINT research, you would go through these and look for information that you could find relevant and useful that could be used later on. So we have one from Noah. Next up, we're going to search for user password combinations in databases. So with this one, you also have to do some digging. So I'm going to do db password is my string, and file type. It's already completed here. So I have to specify the colon when I use this. So let's actually check this one. And as you can see over here, we were able to find a username and a password to a database. Now, of course, actually entering this is illegal, so I'm not going to do that. All right, so the last one I want to show you are, you can find pen test reports that were uploaded online by organizations, and then for some reason they left it open to the public. So we do entitle So basically here, what you want to do is you want to enter tools that pen testers use, and you want those to be your search strings. So we do Nessus, let's do nmap, Dork. And then since we are looking for, a completed report, it's likely going to be a PDF. So let's do that. All right, let's see here. So we found a Nessus scan report of another company here. Yeah, it's pretty bad that it's open to the public, so anybody can see where they're vulnerable now. Let's see what else we have here. Pen test report. All right, so you guys can see that Google Dorking is pretty powerful. Also, if you want more recent results, you can go to tools, and then we can try to filter through this. We'll try past 24 hours or nothing. Try past week, probably. Oh, okay, we actually got one. I'm actually surprised at this. Oh, so this is just a sample report, so it's not that important. Try past month, same one, past year. All right, so I'm gonna go back to my slides. Okay, so now you're probably wondering, how can you prevent this information from being indexed by Google and being available to the public? So There are a great deal of approaches that we could take to abstain from this. The first three things are very simple. So basically, you want to have a practice of encoding and encrypting sensitive data, such as username, passwords, payment details, messages, addresses, telephone numbers, and so forth, especially if you're a developer. Next is you want to run inquiries against your own site to check whether or not you can locate sensitive data. So on the off chance that you do discover sensitive data, you could actually remove it from search results by using the Google Search Console. So that's another tool Google has. The last thing you do is you create a robots text file document on your web server. So basically what this file does is it tells the Google crawlers to which pages can and cannot be crawled from on your website. So this is the intended use of this to actually avoid overloading your site with requests. But then you could also utilize the robots text file to prevent Google from indexing certain pieces of your website. So this is a double-edged sword because should an attacker gain access to the web server itself, they could be able to find this file and see where the sensitive data might be located. So if you do want to create a robots text file, what you could do is define variables here, and then this basically prevents certain parts of the site from being indexed. So the first one basically denies all crawlers from indexing any directory inside of your site. Disallow. So this one is over a specific directory. So the crawler won't be able to access, let's say, the admin user directory here. Oh, and also this other slash will protect the subdirectories inside this directory as well. So disallow private file.html. This one basically restricts access to specific files. So in this case, I mean, it's just a sample, but this one would prevent a crawler from finding information on the file.html. And then disallow wildcard question mark. This basically restricts access to dynamic URLs that contain a question mark symbol. So basically helps prevent bots from looking at your website. All right, so now we're going to get into Shodan. So Shodan is a search engine that can index for any device that's connected to the internet or any publicly exposed web services. So the devices include, but are not limited to webcams, routers, servers, or any IoT device. So it could actually be something as simple as a smart light bulb. Shodan can also find open ports on web servers and servers running on the back end of the IoT devices you may have connected. So Shodan has changed the way threat actors and security teams can discover vulnerable devices. So instead of running scans across the internet, you can find the exact device you're looking for in a specific region by simply using search queries. So Shodan's API is also written in Python, which makes it easy to create scripts and find vulnerable devices, services, and targets in bulk. So basically, it's kind of like Google for internet-facing devices, but unlike Google, what Shodan does is sort of interrogates for ports. It grabs resulting banners and headers it could find, and then it indexes those banners for searching. So the basic thing to understand is that Shodan searches for any device that can have an internet-facing interface. All right, so I'm gonna log into Shodan and just show some of the basics here. Sorry, just a second. Okay, there we go. Share my screen. So I think first thing I want to go into is just some of the plans you can get with Shodan. So there are three plans. Most individuals who want to use this tool should be fine with the freelancer plan. So this is the one I'm actually using for this presentation. And as you can see, you get 1 million results per month, which is more than enough. But you are limited to the types of searches you can perform. So doing more advanced searches and using advanced queries, it will require going up to the small business plan. You could just create an account and use the tool for free, but you're not going to be able to use any of the search filters, which is pretty much essential for conducting OSINT research. So there are two ways to use Shodan. There's the web interface you see here, and there's also the command line interface. So I'm actually going to run the first search on the command line interface, and the next two I will do on the web application. So before we get into that, I want to talk about Shodan's filters. So okay. So the first one we have is country. This basically filters results by a 2-letter country code. Next one is host name. This one filters results by specified text in the host name or domain. Next one is net. This one filters results by a specific IP range or subnet. Next one, OS, search for specific operating systems. Port, this one looks for specific ports open to the internet. Postal, this helps narrow down results by US postal code. Product, this is the name of the software that's found on the internet that's returned in the banner string after a search. Version narrows down on a product further by specifying the version of the specified product. And then last you have vuln. So this is the CVE for the vulnerability string that's found. So for this one, I believe only small business users and up can use it. So I tried using this one and I couldn't get any results back. So okay, so I'm just gonna bring up the command line interface here. Okay, so the first search I'm going to do here is for OpenSSH. So once you have Shodan installed, you do Shodan search, and I could use the port flag. So I'm gonna do port 22. So this is gonna take probably 20-30 seconds because I am looking for literally everything that's open to the internet that this could find. Okay, that was faster than I expected. So basically I could see the IP addresses of servers that are open to the internet on port 22. And interestingly enough, it's also finding the public key, which I actually found surprising. So there are a lot to go through here. So I'm gonna now narrow this down. I'm gonna do the same search, but now I'm gonna look for a city. So I found a decent amount here. Let's try city. Portland. And as you can see, it basically found all open SSH servers in Portland, Oregon. So that's pretty neat. All right, now I'm gonna hop back over to the web interface. Sure. Okay, so for this one, I'm gonna look for open VNC servers. So it's always a bad idea, but you know, a lot of people happen to leave them open to the internet. So I could look for authentication disabled, and then there's a specific string that you could use to find these. So this one was RFB 0308. So I spelled all that right. So as you can see, we have a OpenSUSE Linux server on VNC. It's wide open to the internet. And it even it was able to actually swipe and take a photo of the login screen. So over here, you can see additional open ports for this IP address, for this hostname actually. And then with each port that's open, you get some header information here. And this could be useful for conducting research. So now I'm going to look for OpenRDP. So I could just do port 2389. And as you can see, all these servers are open on RDP to the internet. I was able to find a few that had the screen captured. Which you can see here. So as you can see, we got 3.4 million results. So let's try to narrow this down to city. To Boston, let's say Boston. Okay, so you can see here, we have a Windows Server 2008, and it also has a login screen now. From the login screen, you can, you can deduce a few things. You can find, as you can see here, you can find the username. And, as for a lot of them, they are administrator. Let's go in here. Oh, wow, it's also open on 443. Oh, so basically what these headers tell us is what the port is doing here. And then this is useful if you are doing a broader search, and if they did change a port number to, let's say 3390, which is a common practice. But so I could go into this history tab here, and I can actually see, how many times this was searched from the past and what ports were searched for by other users. And it also gives me some logging information here. Okay, next we have the maps that Shodan uses. So I could basically do the same searches and then, have them populate over a map, which is pretty nice. So I could do port 389. It may take a while because I didn't specify a city. Again, so not surprisingly, you can find these open on places that you expect to have a lot of IT infrastructure in cities. Yeah, so there's a lot more you could do. So those are just some of the basic features you could do with Shodan. All right, so a common question people ask is how do you block Shodan? But that's not actually possible, as it's not a service that's directly scanning over the networks when it's searching. It's basically indexing for information that's already available over the internet. So you're just gonna have in this case you just have to follow best practices for firewall rules, RDP. So like it was already touched upon in I believe the first presentation, you don't want to leave it open to the internet. You only want to restrict it to your corporate network. And if you need other users who are working remotely to access your servers, you want to set up a VPN to do so. And you also want to use multi-factor authentication. So as you can see here, these articles are, sorry, these articles are pretty old, but it talks about how Shodan was used by threat actors to, lead to different data breaches. So another way you could prevent threat actors from abusing this and using it against you is to use the tool yourself, obviously, and use it to find out where you're exposed. So basically, if you go back to search engine, you can actually specify a public subnet here. So you basically want to search for your public assets here and see what you could find. There also is, oh, here it is. There's also is a monitoring feature. I can find it. Oh, here it is. So I don't have an example network to use here, but basically you would just put your public subnet here. You would want to enable notifications, and basically if it finds something like a misconfiguration or whatnot, it will alert you. So that's pretty nice. Also, since we have talked about Google Dorking and Shodan so far, there are common user and password combinations that are not changed on IoT devices that they find after initial setup. So you will notice that admin and root are usually the most common user password combinations. So the best practice here is to simply read documentation for the respective device and change it to a secure password. And yeah, the same rule applies to web servers or any web-facing services you have open to the internet. Okay, so the next tool we'll talk about is SpiderFoot. So this is another popular OSINT research tool. And this one gathers intelligence on IP addresses, domain names, email addresses, personal names, and a lot more. So with this tool, you could just specify the target you want to investigate, select which features you want to enable, and then SpiderFoot will basically collect data, and it will build up graphs and other analytical tools, and it will show you how they relate to each other. So what you could do here is you could actually do pivoting from Google searching or sorry, Google Dorking. You actually use the information you find from your Google Dorks and put in the SpiderFoot and see how it all comes together. So I did run a sample SpiderFoot scan earlier. Basically, how you set up a scan is you just basically define what targets you want, and it could be email addresses, IP addresses, host names. So you do have different options to go through, but I did leave these as default because I did want the scan to complete before presenting. So with this one, what I did was I took one of the MS ISAC reports on malicious IP addresses to be on a lookout for, and I basically just threw that single address in the scan, and I got a lot of info back. So I think the best thing to show here would be this node graph. So what it's done is it's mapped out all correlations and relationships it could find. So finds I was able last time I looked through this, I was able to find the hosting servers, and it was, oh, here we go. Okay, so this one is actually registrar information, but it was able to relate this to a few phone numbers, a few offices, and then it was actually able to find actual physical addresses. Yeah, I was able to find the data server, but it seems like I lost it. But basically, it was able to find, the geo coordinates of the web server where this malicious IP was hosted. So it is a Russian IP. So it looks like I'm running out of time, so I'm actually gonna go to the end. So to prevent yourself from being found online, there's a or actually tell if you already have been found. There are multiple resources you could use. So first one is have I been pwned? So this is basically a database that has a collection of billions of leaked accounts that have been compromised through data breaches. See if I have this open. Yeah, okay. So basically here you just enter an email phone number. So I don't have a throwaway email for this, so I'm just going to use some generic email. Let's say test@gmail.com. So you can see here this one's been involved in 306 data breaches and found 612 pastes. Okay. So here basically you just put in your personal email and you see where your information was possibly leaked. And you probably want to change your password on these websites, as well as the password to your email account, just to stay safe. All right, next we have Intelligence X. So this is another open source information search engine. So it's different from the other ones we talked about because this searches for specific target terms such as URLs, email addresses, and this could also search for Bitcoin addresses, which is pretty interesting. So basically, this also finds searches that are found on the darknet and also the regular surface web we all use. I can just go here. We can do email again, test@gmail.com. And I can actually see raw data from various data breaches here. So you could also find user password combos. Basically, if you type in your personal email here and you see your username and password after downloading this, you probably want to change your user password for the service that was breached, and also probably to your email service account as well. All right, so finally we have dehashed. So this one is similar to have I been pwned, but it offers more search options such as names, phone number, IP addresses, URL. So I think you do need to account for this one. I'm not sure if I have an account here, but basically, okay, so I do need to sign in. Just a second. Try this again. Okay, so this basically tells me where I've been breached, but it doesn't show the raw data like IntelligenceX does. But since you can put in IP addresses and URLs here, what you could do is just put in your public. You could put in some of your public addresses here and some of your public host names, and see if there's any compromises related to those. So that's all I have. So I think I saw a question in chat asking about that Google resource for search engine optimization that you could also use to prevent certain searches from occurring. So this is it right here. So I'm just going to share this in chat. Share that with everyone. All right, so that's all I have.
All right, thank you, Umar. If there's no further questions, we're going to take a lunch break now.